Okay, hello everyone. Welcome to the Swiflearn. My name is Meenal Ma'am and I'm your mathematics instructor. And today I'm here with a topic that is algebra for the class 6th. Alright, so before starting the class, let me introduce you first with the Swiflearn. Alright, so that you have an idea that what Swiflearn is. So Swiflearn is an online teaching platform that provides the interactive classes for the class 6th, 3rd to 10th. All right. So the Swiflearn is 100% live and interactive classes, and it helps the children to get the personalized learning and attention from the tutors. And we have a personalized attention badge with a maximum of 6 students, ensuring the personalized attention and the engagement for every child during the class. All right. And also, we have a dedicated academic mentor team to track and work on the students' progress, and we provide the feedback to every students about their progress. Also, we covers the CBSE as well as ICSE syllabus as per the school exam schedule, and also handle the custom request and arrange the class accordingly. So this is all about the Swiflearn. Let me tell you about the key features of the platform of this platform. We provide the detailed progress reports to the parent so that they track their child's progress. Also, we take the unlimited practice test so that the students check their progress time to time. All right, and also we have a special feature that is a Swiflearn academic test series, that is in short sets, so that we provide these sets on a regular basis to check the students preparation level time to time, and we provide this test on a weekly basis, on monthly and on weekly basis. Also, we have a subjective test for the school exams also. And we have one more features that we can also you can also book a free trial class for free, and you experience the quality teaching from our side. All right, so this is all about the Swiflearn, and let's move. If you have if you have not subscribed our channel yet, so please subscribe the channel, click on the subscribe button and press the bell icon so that you never miss any update from our side and never miss any live videos like this. And if you like the video, click on the like button, comment and share it with your friends. All right. So let's move to today's topic. So once again, welcome you all to today's topic, and the topic for today is algebra. So I hope you all are ready with your pen and copy. So let's start with the topic that is algebra, and it is for the class 6th. So why algebra? What is algebra? The use of algebra in mathematics. I must say the algebra is the base for mathematics. Actually, algebra helps us to think logically and critically to solve many problems both in the studies as well as in the real life. All right, so we will understand the applications of algebra in this chapter. All right, let's move to the objective of today's class. So the objective for today's class is what is algebra? We will learn about the variables and the use of variables in the geometry and in the arithmetic part, and we will learn about the powers and the mathematical operations on the variable. So this is all about the objective of today's class. So let's start the class and give me a virtual high five. Yes, let's start the class together. Okay, so hello Laksh. Yeah, you are saying hi. Hi Laksh. Let's start the class and let's move to today's topic. So, to understand the algebra, let us take some applications to understand what algebra actually means and the use of variables and all. So, let's take this example. I store the tomatoes from my garden in a box, and one box contains 10 tomatoes. All right, so this box contains how many tomatoes? 10 tomatoes. Great. All right, so this box contains 10 tomatoes. Okay, in the next week, I have two boxes of tomatoes. So how much tomatoes I have? Actually, if each box contains 10 tomatoes, then I have how many tomatoes? I have 10 plus 10 tomatoes. That is, I have 20 tomatoes. All right, great. Then next, in the third week, I have how many tomatoes? I have three boxes of tomatoes. This means I have 10 plus 10 plus 10 equals to 30. Because each box contains how many tomatoes? 10 tomatoes. Great. Okay, what about the fourth week? In the fourth week, I have 10 more tomatoes. So in all, I have 10 plus 10 plus 10. plus 10, that is 40 tomatoes in all. All right, great. So what about after a year? How many tomatoes I must have after a year? Now I have 36 boxes of tomatoes. So how much tomatoes I have? As each boxes contain 10 tomatoes. So in all I have how many tomatoes? I have 360 tomatoes. All right, because each box contain 10 tomatoes. Okay, not a big deal. No problem. Let's move to the next one. Alright, what about after the 3 years? Now I don't know how much tomatoes I have. What should I do? Because after the 3 years, lots of boxes are there and it become a complex for me to actually count all these tomatoes. So now the need of algebra actually there. So how algebra help us? Actually the algebra can make our task easy. How? Here we have total tomatoes will be how many? The total tomatoes in 1 year, and if we multiply it by the number of years, then we get the number of tomatoes in the third year. And in this way, algebra help us. So how many tomatoes we have after the 3 years? We multiply this 3 by the total number of tomatoes per year, and the number of tomatoes per year will be 360 degree. So in this way, we will find the value as 3 into 360 degree, that is equals to 1080. All right. Now, the question arises what and how algebra helps us. So algebra, and actually I must say that mathematics and the algebra takes the complex task and put it into a simple pattern. And here, what is the simple pattern? Actually, here the simple pattern is n into the total number of tomatoes per year. And here the number of tomatoes per year will be constant, that is 360 degree. But here the value of this n varies. So we get a pattern here is 360 into n. And here the n is nothing but it is a variable. We can take the value of n as depending upon the year. We can take the value as 1, or we can take the value as 2, or we can take the value as 3 depending upon the year. So after the 3 years, the number of tomatoes will be n into 360 degree, and n into 360, sorry, not degree, n into 360, and here n is 3, so you will get as 1080. And what about the second year? If we want to find the total tomatoes after second year, tomatoes after the second year, then its value will be 2 into 360. That is equals to what? That is equals to 720, like this. So we can find the total tomatoes after any year using this pattern, that is 360 into n. Got it? And this is actually the application of algebra. All right. So let's move to another examples to understand the algebra. Now the question arises here is what this n? So let's introduce the algebra to understand what n is. So let's take another example to understand what algebra is. And actually first we will just define what algebra is. So what is algebra? The part of mathematics in which the letters are used to represent the number and quantities. Once again, it is a part of mathematics in which letters are used. The letters here may be starting from A to Z, A, B, C till Z. We can use any letter, and they are used to represent the numbers and quantities. As we have already seen in the last example, that n represents the number of tomato and n represents the number of year in the last example. All right, so this is all about algebra. All right, let's move to the next slide to have a better understanding of actually how the letters are used in maths and what they are called. All right, so let's take this activity. Here, you are invited to a birthday party. All right, so you are invited to a birthday party, and in the party, you are served the sandwiches. All right, great. Two people did not show up, so two sandwiches are left. Two people are not present in the party, so two sandwiches are left. And there are four empty plates, which means what? Four people have eaten their sandwiches. Now the question arises is how many sandwiches were there in the starting? All right, anyone wants to tell me the answer? Anyone wants to try that? How many sandwiches were there in the starting? Yes, let me wait if anyone gets the answer. Okay, Yes. Let's check. Actually, let's try to solve this together. Okay. So we have 4 empty plates, which means that 4 sandwiches and 2 sandwiches left. That means in total there are how many sandwiches? 6 sandwiches. The 4 sandwiches from the empty plates and 2 sandwiches that are left. So in all we have 6 sandwiches, right? It's so easy. So simply we can solve it. But how we can write this in algebra? Yes, Divyanshi and Ankit, yes, both are correct. 6. So how you can write this in algebra? The question arises. How we can write this in algebra? So let's assume that the total number of sandwiches is n. Here n is the letter and we are using to represent the number that is for moment unknown. Actually we don't know the value of n. So let's take n as an unknown. Alright, let's try. So we know that the total number of sandwiches will be equals to what? The number of sandwiches left plus number of sandwiches eaten. Yes, like this. And if we want to actually express the equation, algebraic equation, then how we can say? We can say like this, that the total number of sandwiches minus the number of sandwiches left, these are the 2 sandwiches that are left, will be equals to what? The number of sandwiches eaten. So we can express our equation like this. Like this, what? Like n minus 2 equals to 4, right? And if we add this 2 on both the sides, so we get on the left hand side we get n, and on the right hand side we get the value as 6. So in this way we can express any situation, any activity by using algebra. All right, I think now you all get it. Okay, so this is all about the variable. All right, let's move to the next one and understand the variable as well as algebra in deep. Okay, so but what this n? Again the question arises now. What is n? So I have said that n is a variable, and let's take how else can we use these letters variables. Okay, so let's take one activity so that we understand how these letters are used. So let's make the letter L using the matchstick. We will take an activity of a matchstick. All right. So the question is how many matchstick we need to make an L, a letter L. So what you will think? How many matchstick we require to make a letter L? Yes. Anyone? How many matchsticks we require to make a letter L? What we say? Simply 2 matchsticks are required. All right, like this. We require only 2 matchsticks to make a letter L. So number of sticks required will be equals to what? How many? 2 matchsticks are required. Now, if I add another L next to the first one, I have to add another L. Then the question arises, how many matchsticks are required? So at this time, I require 2 more matchsticks, and in total, I have how many matchsticks? 4 matchsticks I have. All right. So let's add another L and see what happens. So if I add one more L, what do you all think? That how many matchsticks are required in total to make 3 Ls? Yes. What do you all think? How many matchsticks are required? 2 for the 1L, 2 for the second L, again 2 for the third L. That means you require 6 matchsticks to make 3 Ls. Got it? Actually, here we are with only 3. But what happens if we have to make n numbers of L? Now, the big question. Now it becomes complex. Yes, but I must say, using algebra, this complex equation will become easy for you. How? Let's take. Actually, for 1L, you require how many matchstick? 2 matchsticks only. For the second L, you require again 2 matchstick. For the third L, you again require 2 matchstick. So here, what we can say, actually, the value 2 remains constant. 2 for the first one, again 2 for the third one, again 2 for the for the third one. So for the n1, how many matchsticks we require? 2. So this 2 remains the constant here. And what we can say, the total number of matchsticks will be equals to what? The pattern will be like this. Yes, is it like this? 2n. Let's check. If the value of n, here the n shows the number of L we require. So if I take n equals to 1, so how many matchsticks are required for the 1 L? We require only 2 matchsticks because the value of n is 1. If I take this value n is equals to 2, so what will be our answer? 2 into 2 and the 4. So for the 2 matchstick we require 2 plus 2, that is 4. Yes, correct. So in actually, at last we must say that for the n number of L's, we require how many matchsticks? We require 2 n number of matchsticks. Alright, so in this way, algebra makes the complex activities very simpler. Got it? Great. Okay, let's move to the next activity to have a better understanding of this variables and the algebra. Okay, and here's the next activity. Let's see another pattern. It is a square pattern. All right. So the question is, how many sticks are required to make this square pattern? What do you all say? How many matchsticks are required? Yes. Yes, I got the answer is 4. Yes, only 4 matchsticks. 1, 2, 3, 4. Great. Got it. Now, if I have to make a pattern of 2 squares, then how many sticks are required? Let's count together. Okay, so 1, 2, 3, 4, 5, 6, and 7. So how many sticks we require? We require 7 sticks for the 2 squares. All right, great. Now, if our question become complex and like this, if I have 3 squares, then how many sticks are required? So it's easy. For the 3 sticks, we can count easily 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So for the 3 squares, we require 10 sticks. All right. Now, the complex situation now start if we have to make a n squares pattern using all these things. Now it become complex because we can't count the n number of variables and n number of squares like this 1, 2, 3, 4, 5, 6, and so on. We can't count like this because it becomes tough for us. So again, the application of algebra here comes here. And how? Let me show you the pattern that it follows. Let's see. So the number of sticks required for the 1 square will be what? 4. All right. Now the number of sticks required for the 2 square will be what? 2 square will be 7, as we have already seen, already counted. And the number of sticks required for the 3 square will be how many? 1, 2, 3, and 10. So the question is, number of sticks required for the n square will be how much? Now we have to check. So we see this pattern here. In this matchstick square pattern, we see this pattern. What pattern? The 4 is will be equals to what? 1 plus 3 into 1. 7 will be equals to what? 1 plus 3 into 2. 10 will be what? 1 plus 3 into 3. So can we write our pattern for this will be like this? Because the 1 is constant here. Again, 3 is also constant. And this value changes 1, 2, and 3. So we can take this value as n, where n varies, it is a variable. So we see here we have find the algebraic pattern as 1 plus 3n. Got it? I think you all got it. Any doubt? Yeah, Ankit, you have told me the answer is 1 plus 3n. Very good. Okay, so I think you all understood. And let's move to the next slide to understand what variable actually means. So here is variable, a letter that represents an unknown number or which changes its value will be a variable. So variable is nothing, but it is a letter that represents unknown number and it changes its value. Okay, for example, we know that variable starts from letter A till Z. We can take any letter as a variable. Okay, so here 1 plus x is equals to 4. It's an algebraic equation. And here, which is what is the variable here in this equation? We must say the variable here is x. And what this 1 and 4 are? They are constant terms because they don't change their value. So 1 and 4 are constant and x is a variable because it changes its value. Okay, all right, great. I think now I hope you all understood. Okay, so let's move to the next slide. And we differentiate between the variables and constant. So variables They are the values, they are the alphabet that they can take any value. They can take any value starting from 1 till 1, 2, 3, 4 and so on. They can take any value. And what are the constant terms? The values that cannot be changed. For example, the number 2, 3, 5, they cannot change their value. All right, but the variables take there, they can change their value. All right, now I think you understood the difference between the variables and the constant term. Hope so you all understood this. Yes. All right. So let's move to the next slide. And now we understood the concept of algebra, actually the use of variables in the geometry. Now understood the concept of algebra in geometry. So I think you all remember what is parameter of any shape. I think you all remember. Yes. What is the parameter of a shape? So yes, it is the sum of all the sides. What is parameter? It is the sum of all the sides of that shape. That will be the parameter of that shape. Okay, great. So let's understood the concept of algebra in the geometry. In geometry, how we use the concept of algebra, how we use variables in a common rule of geometry. Okay, now let's consider a square of side L and find its parameter using the algebra. So here it is a square having all the sides equals to L. All right, let's try together that what will be the value of parameter using this variable L. So what do you all think? What will be the parameter of the edge of the square? So we know that the parameter will be equals to the sum of all the sides. Yes. So its value will be, parameter of the square will be L plus L plus L plus L. So that will be equals to what? That will be equals to 4L. Yes, got it? So that will be equals to 4L. And here L is a variable which can be any number. We can take this value as 1, 2, 3 and 4. All right, let's take one example. Let's take an example, and the example will be, if we have a square having the side, that is the value of L will be equals to 2. What do you all think? What will be the parameter of this square? We have a formula for the parameter for a square will be 4L. So if the value of L will be equals to 2, so what you will get as your value, as your answer is 4 into 2, that is equals to 8. Yes, great. That will be equals to great 8. Actually, I got the answer from one of your side. One student answers me 8. Great. Good. So what will be the value of the parameter for the square having the side 2? Its value is 8. Likewise, we can take any value of L and got the answer for the parameter. All right. I think now you understood. You all understood this. Yes. All right. Let's move to the next slide and let's take another example, another geometrical figures. And here is a figure, Yash. So here is a figure that is a rectangle. Now let's find the parameter of a rectangle. So here we have to consider the length and breadth of a rectangle, as rectangle having a length as well as breadth. All right. So let's take the length as L and the breadth as D. Now, so anyone, let's try, anyone wants to try this? What will be the value of the parameter of a rectangle? Yes? Anyone wants to try this? Let me wait for the answer. So what will be the parameter? Parameter is nothing but the sum of all the sides. And here the sum of all the sides is L, B, L and B. We have to add all these. And what we will get? We will get the parameter of a rectangle like this. The parameter of a rectangle will be equals to L plus B plus L plus B. That is 2 times L plus 2 times B. That is 6. In all, it becomes 2 times L plus B. So here, L and B are two variables. We can take the value of these variables according to our choice. All right, so let's take an example here. Shreya Jain, very good. You answer me that parameter of a rectangle is 2L plus B. All right. Now I will give you one example. I will give you one question, that what will be the parameter of a rectangle if the value of L will be 2 and the value of B will be equals to 3. Now anyone wants to try this one? What will be the value of this parameter? sorry, the parameter of this rectangle having length is 2 and breadth is 3. Anyone wants to try this? We have a generalized formula for the parameter of a rectangle as 2l plus b. So I'm just waiting for the answer from your sides. So 2 times l plus b. I'm making it simpler for all of you. So I'm just waiting. All right, let me solve it for, yeah. And Shreya answer me the question as the answer will be equals to 10. And let's check. Yes, 2 into 5, that will be equals to 10. Very good, Shreya. Good. Great. So we have formed the generalized value of the parameter of a rectangle that is equals to 2l plus b. So using algebra and using variable, we can generalize any formula, any geometrical figures formula like this. All right. So I think now you all understood the concept. Okay. Let's move to the next part and let's move to the next slide. Okay. Now here's some questions for all of you. And let's try these questions together. Okay, so here we have to identify the variables and let us just revise what are the variables. Variables are the value that variables are the actually letters that changes their value. And what are constant? And the constants are actually the fixed numbers that do not change their value. Okay, so let's try the first question together. X plus 56 equals to 60, and here we have to identify what? Identify the variable, and variable are the letters that changes their value. And in first question the variable here is x because it changes its value, and these 60 and 56 are nothing but they are the constant terms. Okay, let's move to the second one. The second one is p minus 56 equals to 88. So here 56 and 88 are nothing but they are what? They are constant, and the p here is variable. Great, very good. Then let's move to the third question. Here y minus 1 equals to 5. All right, so 1 and 5 are constant term and the variable term here is y. Got it? Great. Then the fourth one is n minus 50 equals to 100. Here the 50 and 100 are the constant because they don't change their value, and the variable one here is n. And moving on to the fifth one, 30b equals to 90. So here the variable term here is b. Now I think you all understood the concept of variable. I think now till here I think you all have no doubt. Any doubt? Yes? Anyone? No? All right. So let's move to the next and understood the other application of variables and the algebra. All right. So now the question is power of literals. How we can actually represent the power of any literals. Let's take one example. How to write the multiplication of two variables. We can write the multiplication of two variables like this. A into A will be what? Yes, it's A into A. And if I have to multiply the three variable, then again it is easy. A into A into A. But actually the complex arises when we have to write it 15 times. Yeah, now it becomes tough, na? A into A into A, and we have to write it like this 15 times. Then it become actually tougher one, I must say. We have to write a lot. So actually to simplify this, we use the exponential notation. And let's see how we use this exponential notation. Okay. All right, let's see how we will use the exponential notation. It can be written like this. If we have to multiply a 15 times, then we can write it like this. A raised to the power 15, like this. All right, and this is nothing but it is the exponential notation of a variable. All right, let's take one example for all of you. If I have to multiply a, I must say a, how many times? If I have to multiply it for 100 times, 100 times. Then what will be the exponential notation for this? Its exponential notation will be a raised to the power how many times? 100 times. So the exponential notation for this will be equals to a raised to the power 100. Great, got it? Okay, let's move to the next slide. Okay, here we are. So here we are with two of the questions. Write each of the following in the exponential form. We have to write these two equations in the exponential form. Okay, let's try the first one together. Okay, so what we have? 3 into A into A into A into B into B into B. So first take it as 3 into minus 1 will be equals to minus 3 like this. And A how many times? A is 1 time, 2 time and 3 time. So multiply A and 3 times, that means we can represent it like this, A raised to the power 3. And B how many times we have? We have 3 times. So again B raised to the power 3 like this. And in simplified form we can write it like this, 3a raised to the power 3 or b raised to the power 3, or we can say minus 3a cube or b cube like this. All right, so our answer for the first question will be equals to minus 3 a raised to the power 3 and b raised to the power 3. Got it? Okay, so let's solve this second question together. Okay, so here we have 4 minus minus, and you know that in multiplication, minus into minus becomes what? It becomes positive. Yes, I think you all know this. Okay, so let's solve the question second together and just try it together. Okay, here we are. So 4 multiplied by minus 1 and minus 1, so it becomes positive 4. All right. Then talking about the variable p. How many p's are there? We have to multiply 2p. So p raised to the power 2, and we have to multiply 3q. So answer will be q raised to the power 3. So the answer for the second question will be like this, 4p square q cube. Or we can say 4p raised to the power 2 and q raised to the power 3 like this. So using exponential notation, we can simplify our algebraic expression. Yeah, like this. Okay, got it? All of you? Yes? Let's move to the next slide and let's move to the next question. Okay. So, next concept for the variables and the algebra is operations on the variable and numbers. So, how the variables operation take place, we will do this. Okay. So, first of all, just revise how many operations are there. So we have 4 operation. The first is the addition. Yes, the second is the subtraction. Addition, subtraction. All right. Subtraction. The third one is multiplication. Yes. And the last one is what? The last one is the division. Yes, the last one is the division. So we have these 4 operations, and let's take some examples to understand how these operations apply on the variables. Okay, all right. Let's take this first question. Let's add a constant 4 to a variable. So how we can add? So the addition of 4 with this constant like this, 4 plus y. Got it? All right, let's move to some more examples, some more questions. Okay, and here with some more questions. Similarly, can you multiply a variable with a constant? Yes, I can write that. Yes, it's so easy. And let's take one example. Let's multiply 7 with a variable p. So how we can multiply this 7 with a variable p? Let's see. 7 into p like this, that becomes 7 into p, and in simple it becomes 7p. Okay, let's take some more example. If I have to multiply 5 into 3 into q, so what will be our answer? These two terms are the constant terms. So 5 3s are 15, and if I multiply 15 by a q, my answer will be equals to 15q. So we can multiply Yeah, we can multiply the variables also with a constant term. No problem, no issue with this. All right, so let's move to some more operations. And here we have, let's see another operation, but now with two variables. Here we have two variables, the a and the y. So what we have, 7a into y, so it becomes 7ay, like this. Okay, so no problem. If we have two variable or if we have three variable, we have no issue. Let's take another example with three variables and just check whether the operation apply on the variables, the three variables or not. Okay, let's take an example as 3 into A into B into C. What do you all think? Is it become 3ABC? Yes, no problem. So if we have any number of variables, we can use the multiplication operation also on the variables. Okay, I think no doubt is there with all of you. No? Okay, let's move to the next slide and just see this. Can you multiply this expression A into B plus C? Yes, what do you all think? Yes, we can do this. As we know that multiplication follows a distributive property over the addition. What we'll say about this property? This is actually the distributive property. This A distributed to B as well as this A distributed to C also. So what we will get? Actually, we get like this. So we multiply A with B, then plus A into C, and what we will get in simplified form? We get this, AB plus AC. So answer for A into B plus C will be what? Will be AB plus AC, like this. So we have said that the variables, the operations will be applied on the variables. Any operation or out of the four operations, any operation will be applied on the variables. Got it? All right. So let's move to some questions and let's solve these questions together. And here are some practice questions for us. Okay. So are you all excited for these questions? Yes, actually we have learned everything. So we can solve all these questions together. Let's solve it together. First we have to subtract 4y and 3z. So what we have? 4y and we have to subtract this with 3z. So we know that this 3z. All right. And what do you think? It will become 4y minus what? 1 minute, 1 second. We know that minus minus become what? Plus. So what we get as our answer? 4y plus 3z. Any doubt? So the question answer for the first question will be equals to 4y plus 3z, as we have to subtract 4y with minus 3z. So the answer for the first question is 4y minus 3z. Let's move to the next one. Yes, ready? Okay, let's solve this question together. 7x and minus 11. So we have 7x plus minus 11. What we get? 7x minus 11. So the answer for the second question will be what? 7x minus 11. Got it? Yes. Let's move to the third one. So here we have to divide 3x by 3. All right. So the next operation here is division. 3x divided by 3. So what we get? 3x by 3. Or we can say 3 cuts 3 and at last we have only x. Alright, so the answer for the third question will be what? X. Great. Got it? Any doubt till here? No doubt. Let's move to the next one, the fourth one. Okay. So we have to multiply 9y with 2x.